Welcome. This video will cover the CAD object modification in AEDT Icepak. Let's see how to heal, simplify, and remove the unnecessary faces of a CAD object in AEDT Icepak. Here is the AEDT Icepak interface with a blank Icepak design. To discuss the heal command, let's import the CAD geometry first. Geometry healing can be done when first importing the CAD into AEDT Icepak to correct geometric violations that may cause geometry and topology errors. Click on Modeler menu and select Import. Browse to the CAD file and select it. At the bottom left of the Import File dialog window, there are two sets of validations and healing options available: Quick or Strict and Auto or Manual. For Quick Heal, there is no choice of auto or manual, but for strict heal, one can choose among auto and manual. To perform an auto heal, keep strict and auto selected and click open. After importing the CAD, selected objects can be individually healed as well. The basic step in the healing process is to first perform an entity check to see the quality of the CAD geometries. To do so, select objects of interest, go to the model ribbon area and click Analyze. In the Analysis Options dialog window, make sure that Perform Entity Check Errors is enabled. The check level can be basic, strict or comprehensive. Here the comprehensive level will be used. Select check level to comprehensive. This can help determine if there are invalid entities or small entities. Click OK. In the Model Analysis dialog window, analysis results for each object can be seen. The status of analysis results here are good for all objects. The region object was not selected for geometry analysis, so analysis was not performed for it. If there is a problem with any object, it will indicate that invalid entities were found. To heal the object with errors, click Perform at the bottom left of this dialog window and select Heal Objects in the drop-down menu. In the Healing Options tab of the Healing Options dialog window, there are three heal types available: Auto Heal, Manual Heal, and No Heal. By default, Auto Heal is selected, but for more user-controlled healing, the Manual Heal option should be selected. In the Feature Removal Options tab, there are options to remove small holes, chamfers, blends, small edges, small faces, and sliver faces. In the Properties tab, all geometrical properties of the selected face can be seen. Click Cancel since the selected objects already has a good analysis status and need not to be healed. Click Close. Let's now discuss the Remove Faces command. Select the region object and in the model ribbon area, click Hide Selected Object in Active View. For this model, we will defeature a hex bolt. To have a better visualization of the operation, click the Show Only button in the Draw ribbon. Press F to switch to face selection mode and zoom to the bolt object. Select all inner faces as shown here where we want to fill. When the faces are selected, the Remove Faces command becomes active. Click on it. After clicking on the tool, the selected faces are removed and the neighboring faces extend to fill the remaining gap. The Remove Faces command can also be used to remove fillets and chamfers. To remove the chamfer on this bolt, select the bottom chamfered faces as shown here and click the Remove Faces command. Now let's talk about the Simplify command. The Simplify command converts a complex MCAD object into simpler primitives, which makes the model easier to mesh and solve. Press O to switch to object selection mode. Zoom in the model and select the object of interest, which is a heatsink in this case as shown here. In the model ribbon area, click on Show Only Selected Objects in Active View to hide all other objects except object of interest. In the model ribbon area, click on Simplify. There are three simplification types available within AEDT: Bounding Box, Primitive Fit, and Polygon Fit. In the Simplify Bodies dialog window, for Simplify type, select the bounding box and deselect the Clone Original Object before operation. The Simplify command has the option to purge the history of the selected objects. With this option, the original object can be cloned before simplify operation to preserve the original object and its history. Additionally, a primitive history can be created for the new simplified object. Click OK. In the 3D modeler window, it can be seen that with the bounding box simplification type, the heatsink object is simplified into a box. Undo the changes so that we can discuss other types of simplifications also. Press Ctrl Z to revert the changes. Again, select the heatsink and in the model ribbon area, click on Simplify. In the Simplify Bodies dialog window, for Simplify type, select the primitive fit this time and deselect the Clone Original Object before operation. Primitive fit represents the object through primitives such as prisms and cylinders. The cleanup option allows to clean up the model before simplification through removing rounds, fillets and chamfers. With the allow splitting option, the simplify command can split up the CAD object into smaller primitive objects such as boxes or cylinders. Click OK. The heatsink object is split into multiple simple primitives. Select one by one in the 3D modeler window to verify it. Again, undo the changes to discuss the next simplification type. Press Ctrl Z. In the model ribbon area, click on Simplify. In the Simplify Bodies dialog window, for Simplify type, select the Polygon Fit this time. Polygon Fit approximates the object as a polygon swept along its normal direction. The normal is selected as the extrusion axis and by default, it is set to auto. It is good practice to specify the axis directly. For this geometry, we will use the z-axis. Interior points on arc determines the number of points created on a curve for a polygonal profile represented by line segments. The default of 3 is a good starting point. A large value can introduce many points and lead to a higher than warranted mesh count. Length threshold % specifies a maximum length percentage allowed for the line segments on an arc. The length percentage is with respect to the maximum edge length of the profile. If the edge length is longer than the threshold, a new interior point is added until the number of interior points on arc is reached. If the object is not perfectly extruded along a normal, like this heatsink, the allow splitting can be used to create many simplified polygonal objects. Click OK. The heatsink is simplified into many polygonal objects. Select one by one in the 3D modeler window to verify it. Simplified primitives typically lead to higher quality meshes and smaller mesh counts. However, it is not always necessary nor desirable to simplify all bodies to primitive shapes. Every model has its unique modeling objectives. Therefore, for each model, it is highly recommended to balance the time spent on CAD simplifications versus the time spent waiting for a high mesh count model to converge. Thank you for watching this video.